the Department of Engineering Cybernetics. So it might make sense to communicate with you actually the origin of this word cybernetics, because today we have like cyber, something or the other. So this term was actually coined by MIT professor Norbert Wiener in 1948. And he wrote a famous book, Cybernetics. Cybernetics, communication in the animal and the machine. And what he did there was to develop a kind of a unifying theory on how decisions are made, in the sense that you need sensors, you need communications, you need some control laws, and a very simple example would be, as he used in his book, is if I touch a hot plate, I have my sensors, I communicate information to some center, which then reacts on this if I'm outside the comfort zone. So our department took this name actually back in 1973. So we are in, but our focus is more on technology side, or technology rather than perhaps more the human side. So I divide opportunities and challenges related to the ever-increasing amount of sensor data that is becoming available from sensors, sensor arrays, and ICT systems in general. And in particular, how this impacts decisions. Second, I will speak about the Center for Integrated Operations, which is a Center for Research-Based Innovation, SFI in Norwegian terms, which has been a very exciting endeavor for many of us. We feel that we've been able to connect the academic world with academic rules and the industry and industry partners. So we started out with 2 partners 4 years ago, and now we have 14 partners, including most of the big players within the oil and gas industry. And then finally, I will speak a little about how we have organized our international collaboration. Because as I learned from this Transatlantic Science Week, it's all about collaboration. So how do you actually do it in practice? And I will focus on a couple of collaboration axes, one towards Stanford and IBM research in the North America, and another one which aligns with some of Norway's national priorities, namely the axis towards Brazil and their development, which is very exciting. So let me, I also need to acknowledge my Professor Jon Kleppe, my colleague from the Department of Petroleum Engineering and Applied Geophysics, for his contribution to this slide. So let me start off with a very down-to-earth daily example. If you take a modern car today, you will find that it's highly instrumented. There are probably several hundred sensors within it. There are more than 100 microprocessors or microcontrollers. They are interconnected. And why is this important? Well, it's important because it improves the handling of your car. It reduces fuel consumption. And so, in a sense, we are, if you compare cars today with a couple of decades ago, you could argue that they are smarter in some sense. By the way, developing a car today, the software side accounts for roughly 1/3 of the development costs. So these are huge, a huge sector in itself. We are placing more and more real-time data into decision flows. And we are making decisions on different levels. We are performing automatic decisions. What could that be in a car? Well, one example would be your anti-locking brakes. It's not you actually pushing the pedal who's kind of controlling the brake pads. I could have done the same argument along those lines. You have A huge number of sensors feeding into computer systems, controlling parts either automatically or through advisory systems. We have smart grid, the power grid, and the vision of smart grid is exactly the same as going on. And finally, down on the left-hand side, the oil and gas, an oil and gas example. This is the Ekofisk production infrastructure. There they are acquiring tens of thousands of data every second. This has to be digested and used for decisions on short-term and long-term. You also need to digest the data. And digest the data means actually to make sense of it for the type of decisions that you are aiming for. And what does this amount to when you speak to a researcher? What it really amounts to is, to a large extent, algorithm development. So if you visit a researcher in his office, you will very often see that what he's actually doing is that he's in some sense refining some algorithm, either making it faster, making it more precise, something or the other which in some sense helps to improve performance of his or her challenge. As a final part of this first part of my talk, you could in some sense divide data into two parts. On the left-hand side, it's the real-time data. And what characterizes this type of data? Time on this. Most of you know these numbers, so let me move on to the Center of Integrated Operations, or as we call it, the IO Center. So as Mata mentioned, IO in this context means remote operations, collaborative environments. You may have people located in different physical locations, and they need to make decisions on common problems. Further, you have new work practices. You may have limited access. The typical example is that you, instead of having danger for equipment. This is an example of a research project ongoing at NTNU in collaboration with partners at the moment, where one is exploring the use of different sensors, in a sense, unmanned aerial vehicles, satellites, of course, vessel-based sensors. And this fed is how large how much data which is really generated. This is an example from the world's largest oil field, the oil field, run by. And I now want to discuss kind of how one in practice really been very collaborating with the Smart Grid Center, directed by Professor We collaborate with IBM, and as a university professor, when I look abroad, I usually look for universities. But I would like to say a few words about IBM research. This is an organization with 3,000 hub in Norway, the IO Center with Statoil and the other partner companies, work together with, as I just mentioned, with IBM Watson, Stanford Smart Grid Consortium, and some others, and finally with Petrobras and the universities, forming kind of a strategic R&D triangle, and that is actually what we're trying to achieve within this framework of the IO Center. And I must say, we are very grateful towards the sponsors and also towards the Research Council, because having some kind of flexible funding makes it possible for us to do things when opportunities arise.